So in the previous video, we introduced this concept of concentration with regards to molarity. Molarity, which is abbreviated by this capital M, but we said molarity has the units of moles of solute per liter solution. And in the previous video, we did an example where we calculated molarity of a solute as well as grams of a solute. Well, we can also use this concept of molarity and a balanced chemical equation to relate how much, not just of a particular solute that's present, but ion concentrations. So for example, let's say that I was to have a 0.30 molarity solution of calcium chloride, CaCl2. Calcium chloride, that is a strong electrolyte. It completely breaks apart into, and how did I know it's a strong electrolyte? Your solubility rules. That strong electrolyte completely breaks apart into its cations, which in this case is calcium ion, and 2 chloride ions. And so we can use that balanced chemical equation, which is really an ionic equation, we can use that balanced chemical equation to relate concentrations of ions in a solution. So if I have a 0.30 molarity calcium chloride solution, if I want to know the concentrations of each ions present, I can use those coefficients in the balanced chemical equation to relate moles of ion to moles of the entire solute. So in this case, if I have a 0.30 molarity calcium chloride solution, from my balanced equation, I see for every 1 mole of calcium chloride, I have 2 moles of chloride ion. And so I can use those coefficients to do stoichiometry. And so my concentration of chloride ion in a 0.30 molarity calcium chloride solution is 0.60 molarity. And it shouldn't bother you that this number is bigger than your original starting solute, because looking at even just the formula, you see that, oh yeah, I've got twice as much chloride ion, twice as much Cl as I do for the entire molecule. So the only take-home point from this slide is that molarities can be used in conjunction with coefficients from a balanced chemical equation to calculate ion concentrations in a solution. And so, for example, with calcium chloride, in a 0.30 molarity calcium chloride solution, I'm going to have the same concentration of calcium ions because it's a 1-to-1 relationship, but I'm going to have twice as much chloride ion because of the 1-to-2 coefficients.